Hello everyone. So we will continue our solution for internal one paper of data science and we have already completed part A. Now we will see part B, which is dissimilarity and similarity in compelling profiles. So first question is briefly outline how to compute dissimilarity between complaint profiles described by A. Nominal attributes, for example, jurisdiction, police station, offense category by chapter. B. Asymmetric binary attributes, for example, presence or absence of a specific offense elements, criminal force present, property damage present. C. Numeric attributes, for example, estimated loss, rupees, incident duration in minutes, term frequency vectors, keywords, phrases extracted from FIR narratives. So first we will see A. Nominal attributes. So here, how to measure dissimilarity. Since normal values cannot be ordered or numerically compared, use simple matching dissimilarity. Means if x is equal y, we write 0, and if x is not equal y, we write 1. For multiple nominal attributes, the total dissimilarity equals to fraction of mismatches across all nominal fields. Why this work? Because nominal categories only tell same or different. There is no magnitude. Now B. Asymmetric binary attributes. Examples presence absence of offense elements like criminal force present, weapon used, etc. So here 1 is equals to presence is more important than 0 equals to absence. So how to measure dissimilarity? Use Jagged dissimilarity suitable for asymmetric binary data. What the formula? 1 minus number of 1 minus 1 matches upon number of attributes where at least one is 1. Why asymmetric? Because both being 0 does not indicate similarity in offense seriousness. Presence of an element 1 is what matters legally. Now, C. Numeric attributes. Examples estimated financial loss, rupees, incident duration, minutes, and evidence score, etc. How to measure dissimilarity? Use numeric distance measures such as Euclidean distance or Manhattan distance. Standardize z-score distance if attributes have different scales. Why numeric distance? Because numeric values represent measurable magnitude, so distances capture severity differences. Now D is term frequency vectors or text features. Extracted from FIR complaint narratives using NLP example TF, TF-IDF. How to measure dissimilarity? Use vector space distances such as cosine dissimilarity, which is d equals to 1 minus cos theta, or use Euclidean distance in vector space. Now, why we use cosine? Text vectors are high dimensional. Cosine captures how similar the complaint narratives are in terms of meaning, regardless of length. Now we have question number 2. We have let tuples or cases are 22, 1, 42, 10 and 20, 0, 36, 8. Now representing what? Incident duration in minutes, witness present 0 or 1, exhibits evidence items count. Now elect act count. Compute following distances among. We have to calculate distance between these tuples or cases. So we have to calculate using Euclidean and then Manhattan and then Minkowski and then supremum distance. So first of all, we will compute the component wise differences so that it will be easy at each step to calculate the distance using different methods, right? So D1 is 22 minus 20. This is the difference 1. And then 1 minus 0 and then 42 minus 36 and then 10 minus 8. So we get this differences. Now what we will do, first we will calculate distance for Euclidean distance. So what is the formula under the root? Summation of I equals to 1 to 4, since we have 4 differences, that's why 4. We have to just do xi minus yi whole square in a square root. So we will compute the squares, then sum the squares, and we'll put under it a square root, and our value will be 6.70. Now we have Manhattan distance. Manhattan distance, we have to just sum up the differences, that's it. All the differences, we will sum them, and whatever we get, here we get 11, so it is our Manhattan distance. In Minkowski distance with h equals to 3, what we have to do? We have to take cube of the differences. We have to take cube of the differences, sum them, and then cube root. And then the value that we'll get is 6.153. It is our Minkowski distance value. Now supremum distance, nothing. Just we have to take the max of all these differences, which is 6. So our answer is 6. Question number 3. The median evidence or impact score is often a robust indicator for triage. Routine to fast track scrutiny versus detailed legal vetting. For massive complaint datasets, propose median approximation methods, GK quantile, summaries, t-digest, reservoir sampling, analyze time or space complexity, and suggest heuristics to balance accuracy versus efficiency. For massive complaint datasets, storing all values and computing the exact median is expensive, so streaming or approximate median methods are used. First is Greenwald-Khanna quantile summary. Idea is to maintain a compact, ordered summary with rank error less than equal error bound. Now, what will be the time taken per update is O of log 1 upon error bound, and space is O of 1 upon error bound. Pros is deterministic accuracy, suitable in legal domains, and cons is more complex and merge is very costly. Now, second, for T-digest, idea is cluster values into centroids with tighter clusters near median and tails. Time taken is O of log k, and space is very small, few hundred centroids. Pros, excellent accuracy, very easy to merge, good for distributed system. Cons is no strict deterministic bound, probabilistic. Third is reservoir sampling. Idea is to keep a uniform random sample of size k from the stream. Median is approximately median sample. Now time taken is O of 1 per update. Space is O of k. And pros is very simple, lowest memory. We can see that time taken is very small. And cons is accuracy depends on k, error approximately 1 upon root k. Now heuristics to balance accuracy versus efficiency. If deterministic and auditable, use GK. If distributed, streaming, or very large data, use T-digest, best practical choice, and if ultra-low memory or simple code is needed, use reservoir sampling with K chosen by accuracy target. Use larger K or smaller error bound only when impact scores are highly skewed. Now fourth, sample data set with two numeric features per complaint. Responsiveness of accused, support or gain due to infrastructure misuse, scaled from NLP extraction. So this is given complaint and this is F1 and F2. We have given data. Now given a new complaint query x equals to 1.4, 1.6. We have question A. Rank existing complaint by similarity using Euclidean, Manhattan, supremum, and cosine similarity. And B is normalize each complaint factor to unit length and recompute Euclidean distance. So first we will see A answer. So these are the formula we're gonna use for Euclidean Manhattan supremum and cosine similarity. This is the formulas using, and for normalization to unit length, normalize each contained vector to unit length and recompute Euclidean distance. Okay, so we will first normalize unit length and then we will use this Euclidean formula in our solution in B part. Okay, so ranking by similarity. So using the query x equals to 1.4 comma 1.6. So we will calculate using formula Euclidean distances. So C1 will have lower distance and C2 will have the highest distance. That's why it displays at the end. And similarly, we will do all calculations of the distances using different formula. We will use Manhattan. We can see we are getting C1 at top means it is closer, and C2 is at last, so it is far point than everyone. We can use supremum distance, of course, same formula we have to use as given above. We just have to write max, choose max of it. Then we will use cosine similarity. Higher equals to more similar means अगर higher होता है cosine similarity तो वो ज़्यादा similar होता है. We can see that जो greater value है वो यहाँ पे C1 की है, उसे सबसे top पे रखा गया है, मतलब वो ज़्यादा similar है. Now B, we are solving B question. So normalize each complaint vector to unit length and recompute Euclidean. So पहले तो यूनिट वेक्टर पे नॉर्मलाइज करना था, जो कि करा फॉर्मूला का यूज करके. वी आर given this formula, we will use it to solve it, and then Euclidean on normalized vectors, and we have to calculate Euclidean using these. So we have calculated, and we can see C1 is smaller, so it is almost identical, and C5 is very greater value, so it is not much identical. So with it, we have completed our solution for part B, and in further video, we will discuss part C solution. So thank you.